Horses are lovely creatures that possess a wild, marvelous beauty that can provide a thrilling ride. But you better wait to put on your riding gear. Do you have any idea of what to expect when you first get on a horse? The answer is one big math of physics concept. And you want to jump, you say? Well, that by far is the most fun, though more dangerous activities that are possible in horses. But you must be asking yourself, how does it all work? What physics is she talking about? And you mean you're actually physically on the horse when it's jumping?
Yes, it's fun, and the concepts are rather simple. First, we will look at balance, the key to a rider's success. Then, we will browse through the different speed options available on horses and how Newton's laws play a part in that. Lastly, we will discuss other exciting things like potential and kinetic energies, velocity, and acceleration. And you will see horse jumping in the works.
Physics, anyone? How in the world do you stay on a horse?
This answer is simple. Balance. Equilibrium, as defined by Webster's dictionary, is a state of adjustment between opposing or divergent influence or elements. Any and every horseback rider knows that one wrong command or one wrong move can throw her off balance and off the saddle. Because it's one of the balance is important if you look at situations from the physics standpoint. According to the laws of physics, a rider is most stable if their center of gravity is above the horse's and their weight is equally distributed in the saddle. When a rider mounts a horse, it throws the horse's center of gravity off. Now there is even more weight on the front of the horse than it was naturally.
Because the horse's weight is primarily located at its front, its center of gravity is not at the horse's center, but rather more near the front, approximately where its heart is. The rider sits behind the withers, which is slightly behind the center of mass, and reduces the rider's sure-footedness. As the horse moves forward, the rider will feel a force pushing her back. This is a perfect example of Newton's first law of motion. An object remains at rest or in motion unless acted upon an outside force. To account for this movement, the rider has to adjust her position, balancing herself on the horse by distributing her weight equally on both feet in her stirrups. If she sits there, the motion of the horse will cause her to be thrown onto the horse's neck. Thank you, inertia. I'm recording. The walk has a distinct 4-beat rhythm. When the horse is walking, its movement is easily counted for by the rider. All she needs to do is settle her weight into the heels of her feet in the stirrups. The trot. The trot has a 2-beat rhythm to it. It is much harder to adjust to the trot than to walking, because the rider is bounced up and down with each pace. This bouncing causes the rider to be thrown up and down, hitting the saddle pretty hard, easily unseating her if she does not adjust properly to this movement. So what's happening? Newton's third law, for every force, there is an equal and opposite force. The horse exerts a force on the rider as its hooves make contact with the ground. The rider, in turn, is bounced upward. To account for the bouncing, the rider can do something called posting, which is where for every other step or beat of the horse, the rider lifts herself with the push of the horse on her stirrups and misses the horse's jerk. For the second beat, she sits down lightly and then is pushed up again. Also, during this process, the rider must lead more toward the horse's front to keep her from falling backward with the force of the horse. Posting is a controlled way of trotting. The rider synchronizes her post with the horse's, and it makes the ride much less bumpy. The canter. During the canter, which is a 3-beat gant, there is a point where the horse has all the 4 hooves off the ground. This is a much smoother gant than the trot. The speed, however, is much greater than the other 2 gants. And the important thing is to keep the rider's weight distributed equally in both stirrups, and also to keep her center of balance above the horse. Let's talk about jumping. Understanding that the more speed the horse has, the higher it can jump. It is helpful in preparing to jump a fence. The faster the horse goes, the more kinetic energy it has to turn into potential energy during a jump. There are 3 basic gaits that are very common to riders: the walk, trot, and canter. A horse cannot easily jump from a walking pace. If the fence is not very high, it is probably not necessary to have a very high speed when jumping over it. So, a trot may suffice. However, for very high jumps, one needs a lot of speed, and also a large horse. These seemingly logical concepts to a horse rider are also easily explained by physics. The mechanics of a jump. When the horse leaps upwards, it exerts a jumping force on the ground. This force is applied only as long as the hooves are touching the ground. The greater that this force is, the higher the horse will be able to jump, because it increases the launch speed from which it's jumping. Once a horse's hooves touch off the ground, its speed will immediately start decreasing until it gets to the top of its arc, where its vertical velocity equals 0. When airborne, only one force is acting on the horse, and this is gravity. Gravity is the force pulling the horse back onto the ground at a rate of 9.8 meters per second squared. After the horse reaches the highest point of its jump, it starts to descend. Its velocity then increases at the rate of 9.8 meters per second squared until the hooves reach the ground. The rate of gravity is only one of 2 components that make up the picture. The velocity of jumping a horse is a vector that has 2 components, a vertical and horizontal. The one that has already been discussed above is the vertical velocity, which changes at a rate of 9.8 meters per second squared. While in the air, the horizontal velocity stays constant. It does not change. These 2 vectors add up to what is called the resultant velocity. It is important to note that only the vertical component changes and the horizontal stays the same. Another important thing to note when jumping is the range of the jump. When it comes to directing a horse on when to jump, there are a couple of factors to keep in mind. The angle at which the horse jumps will determine how far it will go. The advantageous angle where both the height and range are optimal is 45-degree angle. However, that may not be the best option for certain jumps. Attaining the right height is more important than going a long distance. Generally, the higher the jump, the steeper the launch angle needs to be. Also, there is no knob or button to push on the horse that can set an angle at which to jump at, so the rider has to adjust the horse in other ways. First of all, the rider can make sure to estimate the right time to signal the horse to jump. This involves pacing the horse just right. If the horse leaves too early, it will not make it over the jump, and if it leaves too late, it will knock the jump over. Go.
When a horse jumps, it exerts an upward force. This in turn would cause the rider to bounce right off the horse if she wasn't prepared. Right before the jump, the rider prepares herself for the upcoming upward and forward motion of the horse by lifting her seat from the saddle slightly and settling her weight into her heels. This is similar to what the rider does while galloping. During the jump, she allows the horse to move forward by moving her hands forward and giving the horse enough rein to stretch out his neck. At the beginning of the jump, it is important for the rider to lean forward so that the force of the horse that is pushing her back doesn't overtake the situation. However, if she forgets to lean backward when the horse lands, she is in danger of falling forward on top of the horse's neck. Thanks again, inertia. The impact of the ground coming in contact with the horse's hooves creates a large force pushing the rider forward. This is why it is so important to be prepared for that force and not lean forward too much. This jump is not a very high one by far, and it is relatively easy to jump over. The extent to which the rider has to adjust her weight and position is not as extreme as it needs to be for higher jumps. For the very high jumps, the force of the horse is greater, along with the angle at which it jumps from, and also which it lands. It's that the rider has his stirrups very high on his horse, so as to be lifted very high above the horse's back. This allows the horse to move under the rider without the rider being knocked off.
physics relates to horses. Mwah.